So, very good morning to you. So, welcome to for design of mechanical transmission system course aspect. So, this is a very specialized course, advanced course, discuss about various transmission systems in automobile industry. Particularly, we are going to discuss in automobile aspect. The syllabus, it has 4 units. The first unit we are going to discuss about the gearbox system design aspect. So, when you talk about gearbox system, so we are not going to discuss only the gears or gear design aspect, we are going to discuss as a holistic system. Okay. When you say holistic system, it start from the understanding about the machine tool gearbox, then from there construction about a ray diagram based on the given power and torque, then a build up about the kinematic diagram, then go for the what is the type. After that we are going to discuss about, when we talk about automotive gearbox, this is going to be sliding mesh, a constant mesh, a synchro mesh. So, that is the way we are going to do that. Then we do the complete design, finding out based on the bending strength and pitting strength about the module aspect. From the model, then move to the development of the gears, then we will go for the shaft calculations, bearing selection. Okay. Once a bearing selection, suitable lubrication system, then finally estimating about whether the system within the within the design or not. That validation also we will discuss, including gearbox losses and our safe life calculation. This is what we are going to focus in gearbox system aspect. Then we will move on to the brake system design. In brake system design, again we are going to discuss 4 different gearbox brakes. So, you will have a friction lining based brakes. So, you will have a rotor disc, a drum brake system, then it is called dual servo brake system. So, these are the things we are going to discuss. So, here we not only discuss about the design aspect and also we will discuss about the dynamic, which is very important. When you talk about dynamics, there the vehicle dimension also will come into the picture. How the vehicle dimension is chosen such a way that the brake should be able to stop the vehicle. So, that interaction we are going to discuss in detail in dynamics aspect, and also we will discuss about the thermal aspect of vehicle braking. Then if time permits, we will focus for apart from passenger car, we will go for aircraft, helicopter and hoist. So, this is the one which is focusing on brake system design. Further, we will extend another thing, it is a clutch system design. It is extension of brake, because of their arrangement is same, only the difference is the application. Okay. So, here again we will discuss about, we will learning about design, analysis, dynamics and thermal aspects of clutches, and will finally will discuss the entire clutch design aspect for automobile clutches and centrifugal clutches. This is the third unit which talk about the clutch aspect. Then the fourth unit, the other machine elements, talking about design of shafts, torsion bar, torsion limiting devices, chain, belt drives, conveyor, friction joint, friction drives. Those are the things we are going to discuss. Particularly I will focus more on the chain, belt drive, friction joints, friction drives, and if time permits I will cover ball screws, splines, bushes and linear motion slides. So, these are the 4 topics we are going to learn in this course. So, it is a very vast actually, and the outcome of this this course is, once you complete, you will be able to design your gearbox, your brake and clutch and the other machine elements. So, which comprehensively what happened, you will be expertise of a mechanical transmission system design engineer. That is how the syllabus is framed to cover various aspects. So the references, so they have a lot of references because since this course is advanced course, we are going to refer many textbooks starting from for machine tool aspect Joshi, Mehta for machine tool aspect, then we will discuss for gearbox aspect Nomier, Peter Lindvander, Stephen Rajbeach, Damir Jelska, Geethan Maitra, Alan Stokes, UC Jindal. These are the books for gearbox. And for your information, have you heard any textbook for gearbox aspect as such? There won't be. There is no any textbook for the gearbox aspect, interestingly. And then you can see that Rothbard and Newcomb, Andrew Day, Rudolf Limpert, Bert, Neyman, and these are the for brakes and clutches aspect. And Shigley is for the covering a standard design book for comprehensive basic understanding of gears, brakes, clutch and friction elements. So these are the references. So prerequisites, as you know that since this is advanced design course, obviously you should know about the strength of materials, that is basics, engineering mechanics and design of machine element. These are the three courses you must have done in the prepared to attend this course. This should have knowledge of these courses so that it will be very useful. So design of mechanical transmission system. In this first system, we are going to discuss about gearbox system, and you could see this is the transmission. The entire gearbox is given, and this is the transmission where select gear selection mechanism. Okay, and you can see the very nice gearbox system, which comprising of the flywheel to gearbox, right, and all this auxiliary units are given. And prerequisite knowledge before going to the gearbox system, you should aware of the gear types. When you say gear types, it's talking about spur gear, helical gear, mostly used in automobile aspect. So nomenclature. So when you talk about nomenclature, you should able to understand about the module, pressure angle, addendum, dedendum, face width, right, and tool depth also, right, those things, because those are the very critical for the gears. But since advanced, we are not going to discuss, we are going to discuss in the module itself. Once you model, that's other things are taken care of automatically. Yes, you understand when the gears are meshing, what are the forces are acting. Okay, so how the tangential force is acting, not only tangential force and the radial force, how these forces are responsible for the stresses aspect. When you talk about stresses aspect, we are talking about a bending stress and a fatigue stress. These critical two stresses are, you need to aware of that. So famous Lewis equation, right? Have you heard Lewis equation? So that is the equation is going to come into the picture. Of course, correction factors also will be there, and you should know about the shaft design, bearing selection. I am going to touch, okay, doesn't matter. Still, I am going to give you a brief introduction, so that a recap of these things, and you are able to follow it up. Then finally, lubrication selection. Okay, so these are the thing is going to be as a prerequisite. Now we will come back to the actual design of gearbox. Okay, a gearbox consists of a mean of a transmitting mechanical torque between two shafts with a structural support between them. Normally, it is constrained within the casing, which provide structural support and also containment and safety function. Okay, you could see this very nice the gearbox system. This is the input shaft. Okay, the input, I am just focusing only the gearbox system. From there it goes to the you can see this is called counter shaft or else lathe shaft. From the lathe shaft you will have a output shaft. This is the output shaft, will goes to the next stage. Okay, and of course, so you can see that the shift fork and shift rail for selecting the first gear, second gear, third or fourth, including reverse gear, right. All the gears at will be selected through the gear selection mechanism using shift fork, which is the stick which always there. Of course, now you have a advanced automotive also, where you can use, instead of stick, you can just automatic gear system, you can just change the knob and change the gears, that is also there. Okay. Question is, so what is the difference between manual transmission and automatic transmission? Just keep in mind, that is one question. Okay, which is good in terms of performance wise, in terms of fuel economy wise, okay, in terms of comfort of the driver aspect, right. So these are the questions I will answer as we go on. And do you think the gearbox purpose is only for speed aspect? Do you expect any other function apart from selecting the speed? Torque, okay, torque also there, and you can see here, this is a generic arrangement. Normally you will have an engine will give power through combustion, then through engine it goes to a flywheel where energy is stored. From flywheel you will have a clutch to transmission, which is a gearbox, from gearbox to a drive shaft, and finally you go to differential gear, then a rear wheel. This is the how the transmission moves from engine to wheel. Okay. In fact, you can look at this again, top view, engine, traction clutch, transmission, differential gearbox, then you will have finally in the axle, from the axle goes to wheel. This is how the transmission takes place. Okay. Gear function, that is what I said. When you talk about gear function, its structural support for the shaft, bearing and the gear loading also. So we always thought gearbox only for gear speed aspect. No, it is not only speed, and also should able to support the entire structure, that is one thing. Transfer torque reaction to supporting structure or for the drive element. Okay. So this is the reason. So why what is the advantage? Instead of there is no casing, just gears alone, do you think that is feasible? It is not, because when you want to repair the gearbox, it is easy to take the entire gearbox. That is much easier than the taking the individual gears or shaft. That is cumbersome. So now you know that why we take it as a gearbox instead of the gears alone. So the containment of lubricant. So when you say the gearbox, that sump itself, the bottom itself will act as a sump. So obviously containment lubricant and exclusion of foreign matters. You don't want any debris or dust enter your system that going to affect the gears. Provision of safety, obviously the important thing, noise barrier. You don't want to hear the noise. So when you drive a nice car, you want to have a comfort, right? Maybe you can listen nice music also while driving. So if your gear noise more than the music, what happened? Yeah. So it should be, the gear noise should be contained as small as possible, as low as possible, and more importantly, dissipation of heat generated by the friction, that has to be removed. Right, that is need to be removed, and ultimately unitization of assembly, thus aiding testing, installation and maintenance much be easier as a one unit, single unit, gearbox unit. Okay, and more importantly, enhancement of visual qualities. When you take visual quality, aesthetic look, that is also very important for a gearbox system. Yeah. So now we will go for the types of gearbox when talking about physical arrangement. When you talk about physical arrangement, you can see that you can have a parallel shaft arrangement, a perpendicular shaft arrangement and squeeze shaft arrangement. When you talk about parallel, you will have a spur, helical and epicycle, and perpendicular bevel, worm and spheroid, and this cross shaft is crossed helical. This is the way configuration, and within that we are talking about single stage If the stage wise, you can have single stage, two stage and multi stage. You can see this is a nice small gearbox given. So you have only two gears, this gear 1 and gear 2. This is actually a single stage. So it's going to be reduction. Gearbox purpose is you want to reduce the speed. Okay. Let me ask one question before moving to things. What is the need of the gearbox? You have seen the configuration: engine, flywheel, clutch, then gearbox you have. After gearbox you went to the universal joint, then went to the wheel. So can we take off the gearbox, straight away join engine with the wheel? Is it doable? Is it doable? What is the need of the gearbox? That was the question. So what happened if there is no gearbox? Straight away connect the engine to the your wheel through other arrangement. So just think about it. So this is the gear configuration, two stage. You can see that we have a 4 gears. You can see that, right? There is a this is one. It's a missing here. Then again you will have a from here to here. This is a 2 stage. This is configuration. Then you have a multi-stage. You can see that this is a typical automobile gearbox. It's a multi-stage gearbox. You can see this is the gear selection mechanism, right? You can see the gear. These are the gears. In between we have a dog clutch, and this is gear selection. Then you have a output shaft also. So we'll discuss in detail as we go on. And this is we're talking now. We'll move on to the gearbox application. We talk about machine tool. Okay. Prior to the machine tool, what is the typical range you would expect in the automobile gearbox? Usually you will have a 4 forward speed, right? Forward speed, 1 reverse. This is what your configuration. Otherwise you will have a 5 forward, okay, and 1 reverse. Sometime you may have 7 gears also. 7 gears also. 7 forward, 1 reverse. So this how arrangement is given. Okay, very small things. Okay, whereas the moment you go for, apart from these gears, have you heard about any other speed in the gearbox? How about tractor? Tractor, what will be the tractor speeds? How many speeds for tractor? Maybe 24, 28 speeds. So we have off-road vehicles and different speeds also, off-road vehicle. So this machine tool gearbox. So the application is different. In automobile gearbox, you want to have a specific speed. Okay. In machine tool purpose, you need to have a more precision for depth of cut. More feed and depth of cut, you need to have a more precision. That's why normally the machine tool will have a different speed. You can start from 12 speed, 18 speed, 24, right, and 28. They'll go for a very high speeds. And you can see this is for helicopter. Again, you have rotor. Remember rotor, that's the very important thing, right, for helicopter aspect. Which achieved, this is actually planetary gear setup. You can see that this is actually, it's a planetary gear setup, which is you can have a high speed ratio reduction, right. This is the one, and this is the another important thing is windmill. Okay, you will have see that this is your blades, then this is the hub, from hub to the gearbox, gearbox to generator. Okay. The unique difference, the dynamics difference here, in automobile you want to reduce the speed. Okay. In windmill you want to increase the speed. The more the speed, the more the electricity. So both are very different. Though application, right, you can understand that. Okay. So in windmill you will have a usually epicyclic gear train in the first stage, then regular. You will have a regular 2-stage gearbox, helical gearbox, such a way that you can have a high speed. So the dynamics are different. So characteristics, you can see that this is the list of the characteristics of the gear types. It's given spur, helical, epicycle, bevel, worm, spheroid and crossed. So against shaft orientation, speed, reversibility, countershaft and power weight and mechanical efficiency. So we will focus about the more importantly this is the speed aspect. We will focus on the speed, we will focus on the power weight and we will just to understand about and mechanical efficiency. If you look at as you move on to spur and helical, the reduction is 60:1, 80:1. The moment you go, you can have a 50:1. So high speed reduction or up, either way you can use it. So this is very advantage. Of course, you can have worm also. The difference is worm is the friction will come into the picture. Worm is like a screwdriver. It's like a screwdriver. The more the friction, you can transfer more power, but problem is look at the efficiency 40:80. Okay. The next one, the power weight ratio. In a windmill or machine tool, the weight is not a problem, right? But when you go for automobile, the weight is more problem because you want to have a as compact as possible, as light as possible, so that the fuel economy better. Okay, so that is very important. When you talk about gearbox design, it's not only the design the gearbox, you have to optimize such a way that the fuel economy should be improved. Optimizing, okay. Look at this, the power weight ratio good for spur, helical also fair and excellent for the epicycle gear train. And if you look at the mechanical efficiency, the highest one from spur gear is 92, helical is 90 and epicycle 85. So they are in the close range. So among them you can see clearly spur, helical are preferred for automobile applications, right? You can see that straight away, you can see that spur, helical are preferred, epicycle also there, but epicycle will be different application, may not be for automobile, that is the thing. Now we will move on to the gearbox design. Purpose, when you talk about when you design the gearbox, what is the purpose? Okay, so we have a lot of purposes. Okay, one is speed reduction or speed up, that is one thing is there. Within the application also you can change the purpose also, right, that is there. So you can have automobile, you can have off-road vehicle, for not only that home applications or machine tool gearbox, all those purposes. Quality, when you talk about quality, it is a very critical aspect. Okay, let me give you 4 important things. Okay, you have a watch, okay, then you have a watch, right, you have a watch, then you have a automobile gearbox. Now I would not say automobile, I will say machine tool. Machine tool gearbox, and finally you will have a automobile gearbox. Let me ask you, which one will have a higher quality? High quality, which one, for which application do we need a high quality? So watch is the high quality because it is a very precision, very precision, okay, that is very important thing. The next thing is a machine tool, because you need to have a appropriate depth of feed and speed, both you need to know that. So that is one. Automobile, next quality will come. Okay, I will give you example. So the vehicle supposed to run 0 to 30 km for first gear. So that means you have wide range. You can have 25 km also, right? You can have 30 km also. You can even increase 35 km. Does it going to affect any performance? It won't be. Maybe it little, but compared to watch and machine tool it will affect. So you may not have the proper machining operation. If you compromise the quality, then that will affect your watch function also. So the quality is very important. Same thing, right? So talking about torque, okay. So what is the torque? So when you talk about torque, again, what type of vehicle you are going to use? Are you going to use the passenger car? Are you going to use it for the tractor or truck? I am talking about truck. If not, machine tool. Depends on the thing. The torque also will play the vital role. Gear dimensions, okay. So how big you want to, or how compact you want to. The gear dimensions very critical. Then gear specification. When you talk about gear specification, so gear dimension in automobile, most important parameter would be your center distance. Do you know why? What is the reason for center distance? Your space is limited, so you have to specify your gearbox within the center distance you want to have it, okay. Whereas machine tool also even more specified. Watch where the gears are there, even more specified, okay. How about sugar cane? You have freedom, right? For sugar cane they have gears, right? So you have a freedom, that should be fine, okay. So the gear dimension is very critical, okay. Then gear specification. When you talk about gear specification, what type of gears you are going to use it? Whether you want to use a spur gear or helical gear. Within the helical you have a herringbone also, the opposite, double helical. That is also very important. Double helical will remove the axle so that the transmission is very smooth and comfort. Shaft design. So once you have done the purpose, understanding the purpose, quality, torque, gear dimension, gear specification, top design, then you need to go for the bearing selection and lubrication. What is the lubrication? What is the quantity of the lubrication? How heat balances happen. If the more heat is generated, then lubricant loses its viscosity, obviously the performance goes down, right. Power losses, and finally gear case dimension. This is how we will do the gearbox visit aspect, okay. Thank you.